All right, lesson 6-4, nth roots. So by the time we're done with this lesson, we should be able to simplify nth root radicals. Okay? Now, an nth root is for any real numbers, a and b, and any positive integer n. If a to the nth equals b, then a is the nth root of b. And when we're doing even roots, the principal root is referring to the non-negative root of our even powers. So if we take the square root of something when we're simplifying, we don't need to worry about that plus minus for the answer. So we only care about the positive answer when we're simplifying. Now when we go back to solving, then we're going to need to remember that plus minus. So to help us, I have put together a list of perfect roots. So I would pause the video right now and copy down this list somewhere. So when we're looking at it, these first two columns represent perfect squares. Here we have a list of perfect cubes, and I accidentally got a little out of order when I was writing this, so the sixth root I have later on, so I put a star there to let you know so that when you copy it down you can do it correctly. And then we also have a list of perfect fourths and a list of perfect fifths. You can also, it might be better, so I have a note card, so I put, let me zoom in real quick here. I put all of those things on a note card, and this is just to have as a quick reference. And the way that we're going to use this, so if we're trying to take a square root of something, so let's say we're trying to take the square root of 225. On this side, I'm going to go and find that number. So here's my 225. So the square root of 225 would be 15. Or if we're dealing with perfect cubes, so let's say I wanted to try to figure out the cubed root of 343. So again, I'm going to go down my list and find that. So the cubed root of 343 is 7. Okay. Same thing, so my perfect fourth, so I'm looking at these numbers. So if I take the fourth root of 81, my answer would be 3. And then same thing with fifth roots, and I also have one sixth root, or two sixth roots, just in case we need them. And you can extend these lists, or if you need to just kind of create it on your own, you can use your calculator to help you do that. But like I said, sometimes it's nice just to have this list there as a quick reference when we start simplifying these. All right, so back to the notes. So when we are looking at radicals, most of the time we're just used to seeing it as a square root symbol. Now, when we change that, we're going to see a number inside the hook of this. And this is called the index, or like I said, I've been calling it the root of the equation. Okay? And then the actual symbol here, that's the radical sign. And then inside that number or variable, that's called the radicand. Okay? So again, if we were working on simplifying, so the cubed root of 216, so I'm going to go and try to find that number in my list of perfect cubes. So here's 216, so my answer to that would be 6. Or if I'm taking the fourth root of 16, so I'm going to go again to this list, I'm going to go down until I find it. So here's 16. So the fourth root of 16 is 2. Again, square root of 16, we should know that one. That one would just be 4. And again, normally we don't see that 2 there, but if we do the square root of something, so like the square root of 81, that would just be 9. We can also do this with variables. So if we kind of go back and do a little bit of review. So let's say that I had x squared cubed. Okay, so x squared cubed. To do this, we would multiply the powers to get x to the 6th. So if I do that backwards, so let's say I wanted to do the cubed root of x to the 6th, instead of multiplying the powers, we're going to divide. So 6 divided by 3 would give us x squared. Okay. Or if I wanted to do the fifth root of x to the 20th, so again, I would take 20 and divide it by 5 to get x to the 4th. So if you're dealing with variables, that's how we are dividing the exponents instead of multiplying them. And if we are working on simplifying, so if we do a quick example of that, so let's say we were trying to simplify the cubed root of 16x to the 6th power. Now if I'm looking down my list of cubes, 16 is not on that list. But just like with square roots, we can split this number apart by finding a perfect cube that divides into it. So 16, I can multiply or divide 8 into it. So we would split this as the cubed root of 8 times 2. And then since I can take 6 and divide it by 3, that one I can just leave alone. So this is still going to be x to the 6 for right now. So now we would have the cubed root of 8, which is 2. And then I would divide. So 6 divided by 3 is 2. So then this would be x squared. And then we would still have the cubed root of 2 on the inside. So that would be the simplified answer to that one. All right, in the next video, we're just going to go through a bunch of simplifying examples working with our exponents.